while you're up there, throw your wrappers away.
Hey, how many stuff?
Okay, so once you study linear and quadratic, right? We did linear, it's a line, quadratic, a parabola. You can now take everything and just do a whole chapter on polynomials. And polynomials look like this. Here's a bunch of examples where x is with your coefficients and x's are raised to some kind of power, like 4, 3, 5, 7, 11, right? X is raised to any power. Okay? So we study the first 5 polynomials. Degree of 0 means there is no x. That's a 0 degree. Linear, of course, is a first degree when there's a 1. Second degree, we just got done studying that. That's a quadratic. Third degree polynomials, cubic. Fourth degree polynomials, see how I'm just pointing to the highest power in the polynomial? That's how you know what degree it is. You look and I see 2 and I see a 4. 4 is the biggest, so that's the degree. And that's a quartic here. Again, 5 is my biggest power. That's going to be the degree. And 5 is a quintic. Okay, so you look at the polynomial, whatever the highest power is, that's what your degree is going to be. And then the number of terms, that's how you name it. So see, this is one term. There's only one thing there. This is 2 terms. This would be 3 terms. This would be 4 terms. Okay? And we have names for those. 1, mono means 1. So 1 term is a monomial. Bi means 2, so if you have 2 terms, it's a binomial. 3 terms, like a tricycle, trinomial. And anything more than 3 is just numbered like 4 terms, 5 terms, 6 terms, and so on. Okay. So the first thing we're going to do is, given a polynomial, put it in standard form. Standard form meaning biggest power to the smallest, descending order. Give me the name, right? You name it by its degree. And then tell me the number of terms. Is it monomial, binomial, trinomial? Okay. So let's see the first one here. So this is negative x to the 5th. So what would that be? It's in standard form because there's only one term. So what would be the name of that?
Monomial.
No, that's the number of terms. Monomial is the number of terms. What's the name? It would be a quintic, right? The name would be a quintic. The number of terms would be a monomial. Name is this, right? Name is like cubic, quartic, quadratic. Number of terms is monomial, trinomial. So in this one, I need to put it in standard form because which term should be first? 12x to the 4th should be first, then the 3, because this is a degree of 4, that's a degree of 0. So I look at the highest power, and it's a 4. So the name of this is going to be quartic, right? 4 quarters in a dollar, 4 quarts in a gallon, quartic. And the number of terms, there's 2 terms, so I call this a binomial. Very good. Try another one. So this one, is that in standard form? No. What can I do? They both have the same degree. So those are actually like terms that I can combine. So 6x cubed minus 1x cubed, 5x cubed. That's standard form. If there's any terms to combine, you got to combine them. It's a degree of 3, so this would be called a cubic, right, because it's cubed. And I only have 1 term, so number of terms would be monomial. How about the one below it? Is that standard form? No. Which term should be first? Negative x to the 4th should be first. These are both squared terms, so I can combine those. To 3x squared. That's standard form. The biggest power is first. All my terms are combined. This is a 4th degree polynomial. So the name of that would be quartic. Good. I have two terms, so the number of terms would be binomial. Okay. Couple more. So standard form for this one, what term's going to be first? 5x squared, then what? Good, and then 8. Good. 2, 1, 0. Descending order. What would the name of this polynomial be?
Cubic.
No.
What? There's 3.
No. It's a 2. The highest power is 2. So that's a quadratic. You're thinking number of terms. There's 3 terms. So the number of terms would be trinomial.
Oh, ours actually has a 3.
Oh, you're looking at the next one over, I bet.
Oh, it says 18 and it has a 3. Like it's 4x plus 5x cubed plus 8.
So 17, is that standard form? What do you notice about all 3 of those terms? They're all x cubed. These 3 terms are like terms. I can combine all of them. So 7 minus 10, negative 3. Negative 3 plus 1, negative 2x cubed. What would be the name of this? Cubic. How many terms are there? 1, so monomial. Good. So when you're looking at the ending behavior, you have this chart, right? But if you know linears and quadratics, you can just think linear and quadratic and have ending behavior. So if A is positive and it's an even degree, up, up, but if A is negative with an even degree, it's down, down. Odd degree polynomials, right? Cubic, linear. If A is positive, it's down, up. If A is negative, it's up, down. So those are your 4 ending behaviors. So you have to look at the leading coefficient, if there's negative or positive, and then what type of polynomial you have, even or odd. So let's look at these. So this is a negative leading coefficient, because negative 7, and it's a odd degree polynomial, right? 3 is odd, and it's negative. So negative odd would have what kind of ending behavior? Negative, odd, up, down. Okay, this one, I have a positive leading coefficient with an odd degree. So positive odd would be down and up. This one is positive, and it's 4, so even. So positive and 4 would be up and up. Good. And this one's a negative with 3, which is odd. So negative odd would be up and down. So the only way that gets trickier is if it's not in standard form for you. Right? If it's not in standard form, you just can't look at the first term. You have to think what term would be first. Okay. So this one, I'd put it in standard form first. And then here I can say, oh, it's positive with an even degree. So positive and even degree would be up, up, right? A quadratic. Think quadratic. This one, still, it's not, right? Standard form, it's not in standard form. So I'd put it in standard form first. And now I can see, oh, it's negative with an odd degree. Negative with odd degree would be up, down. This one is in standard form, 7, 6, 0. So I see, oh, it's negative of an odd degree. Negative leading coefficient of odd degree is up, down. Good. And the last one, again, standard form. This is a positive with an odd degree. So positive with odd degree is going to be down, up. Good. Okay. So just some basic properties of polynomials, right? Naming them, given like some properties of them, how many terms, ending behavior. So the last thing I want to look at, there's only 3 things today. The last thing I want to look at is if I give you a data set, how can you tell if that's linear, quadratic, cubic, quartic, and so on? When we did the chapter on linear functions, we knew they were linear because everything in that chapter is linear. When we did a chapter on quadratic functions, we knew it was quadratic regression models because everything in that chapter is quadratic. But now that I'm looking at all of these different polynomials and I have a data set, how do I know which polynomial is going to represent that data? Okay, so I look at the differences in my y values. And differences in algebra mean what? What does difference mean? What operation? Subtract. Okay, so this is what you're doing. You're subtracting the y values. So I would say 7 minus 16 is what? Negative 9. Good. 2 minus 7 is? Good. 1 minus 2? 4 minus 1. Okay? These are called my first differences. They don't equal each other, right? They're not all the same number. So this is not linear. So then I do my second differences. Negative 5 minus a negative 9. 4. Negative 1 minus a negative 5. 3 minus negative 1. See how my second differences are all the same? So if my second differences are the same, then this is a second degree polynomial and it's quadratic. So whatever differences match, that's the degree polynomial you have. Let's do one more. So you're just looking at the y's. Negative 9 minus a negative 15. 6. Good. Negative 9 minus a negative 9. Go. Negative 3 minus a negative 9. 6. Right. Not negative 6. 6. Okay. Those don't match, right? So I go to the second differences. 0 minus 6. 0 minus 0. 6 minus 0. Do my second degrees match? No. So now I go to the third differences. 0 minus negative 6. 6 minus 0. Do my third differences match? Yes. So this is a third degree polynomial, and we say that it's cubic. Okay? You're just doing the differences. Whatever differences match, that's what it is.